I'd like to introduce us to the second logarithmic law. The second logarithmic law. It's very simple and very straightforward, and rather very similar to the first logarithmic law. And let's rewind and try and remind ourselves what exactly the first logarithmic law is. Well, we learned that the log to the base a of b plus the log to the base a of c, right, is equals to the log to the base a of b times the c. Okay, this is what we learned as our first logarithmic law. The second one, and I personally just like to call it second because this is the first one, right? I like to call the one we're going to introduce ourselves to the second personally because, well, it's not exactly known as a second, but I like to think that if you know this as your first, the second should make just as much sense. So let's see what the second law says. Well, the second law, let me just cross this out so you don't get confused. The second law is log to the base a of b, right, minus the log to the base a of c. This would be log to the base a, notice this, b divided by the c. Divided by the c. As you can tell, alright, the first logarithmic law deals with the addition. It deals with the addition of logarithms. And when we add the logarithms, this b here, right, times is multiplied by the c. So the addition of logarithms leads to the multiplication of these numbers, which I like to call the results, right? And when we're on the second logarithmic law, we're going to be subtracting logarithms. And subtracting them is basically, when we're subtracting them, it's basically leading to division of the logarithms of these values b and c. As you will see in the examples below, you probably get the hang of it. And I always like to encourage us to always get the hang of these things and, get very used to them. Go ahead online and grab a couple questions from where you can, alright? So let's try and do a couple of questions here. Let's say I said we had log to the base 3, for example, of 7, okay, minus log to the base 3 of 14. This would be equals to, and you can have a glance at the law up here. This would be equals to log to the base 3 of b, in this case, which is our 7, right, out of c, which is a 14. Okay? And I can simplify this by writing log to the base 3 of 1 over 2. And if you're not a man of fractions, go ahead. Put it in decimals if you like. Go ahead, right? And you can say it's log to the base 3 of 0.5. Right? So it's a little straightforward. Let's have a look at another one. Let's say we had log to the base, let's say 5 of, how about 35, alright, minus log to the base 5 of 7, for example. 7, for example. This would be equals to log, right, base 5 of 35 divided by the 7, right? And you can have a look at the law. I'm just taking you back up so you can see that we're doing exactly what the law states. Well, let's see what happens when we simplify this. This would be equals to log to the base 5 of 35 divided by 7 is simply 5, right? Well, hold on. Notice something here. There's something here worth being suspicious of. You got log to the base 5 of 5. And I can simplify this, and I'm just going to show you exactly how, but I can simplify this to make it look a lot neater, a lot easier, a much more beautiful way, for example. Well, let's first state that log to the base 5 of 5 is equals to x. Well, we can convert this into our exponent form like we had seen in previous videos, where I know x is the logarithm or the power that I raise 5 to, okay, to give me this value, to give me the 5. So I know 5 to the x is equals to 5. And 5 on its own is exactly the same as 5 to the power 1, right? Therefore, I can conclude that x is equals to 1 because they're basically the same thing. Most math books, as I've shown you previous times, you just can cross this bit out and you can say x is equals to 1. Okay? So this whole equation, log to the base 5 of 35 minus log, let me just make this a clear 5 down here, log to the base 5 of 7 basically boils down to just 1, and it's quite cool how it does that, right? Let's go back and try another example. Let's say I had log to the base let's say 8, okay, of 72, right, minus log to the base 8 of 6, for example. And if you like, let me just scroll this back up so we can have a look at what the logarithmic law states. And it's basically b minus c, which is b divided by c. I'm just doing this so you can, get the hang of what we're doing. So this would be equals to the log base 8 of 72 divided by the 6. That would be equals to log to the base 8 of 12. And these kind of questions are not too tricky, nothing too complex about them. You can just go online and try as many questions you can, and you become very natural to them. Now let's try something interesting. Let's try maybe something algebraic if we like. How about that? Let's say I had log to the base 5, all right, of 3x, okay, minus log to the base 5 of let's say 9, okay, is equals to log to the base 5 of, how about maybe 27, if I may. Okay. Oh, by the way, let me point this out. Notice, just like in the first logarithmic law, they're all to the same base. They're all to the same base, which is log of a. And so is in the second logarithmic law. They have to be to the same base. Please don't forget that. Okay? So let's try and solve this equation we got right here. We have log to the base 5, all right, of 3x divided by the 9. That's what I've just done. I've just simplified this equation into log base 5 of 3x minus divided by 9 because it's a fraction, right? And I know that this is equals to the log base 5 of 27. And as I showed you in the previous video, you can choose to cross this out if you may, or just think about it reasonably, and you can conclude that 3x over 9 is equals to 27. 3x over 9 is equals to 27. Well, we can simplify this a little further, and I like to simplify it and say 1x, all right, over 3. What I did was just crossed out the 3. Cut this out by 3 and made it 1. Cut this out by 3 and made it 3, right? So that's 1x over 3 is equals to 27. Therefore, x is equals to 27 times the 3. All right, this would be equals to 1, carry the 2, 3, 6, 8, 81. And that should be pretty cool. And if you don't believe me, what you can do is just plug in 81 where the x is. So you can go ahead and say log to the base 5 of 3 times, or I'll just put in times 81 minus log to the base 5 of 9. And if you compute this, you'll get a certain value, decimal, I'm not really sure. And you should compute log to the base 5 of 27 as well. Okay? Of 27 as well. And you notice that you will get exactly the same value when you compute it on a calculator of some sort. And please don't forget, just like I mentioned just a couple seconds ago, always to the same base. You would struggle and probably get confused, or probably not even know how to do it with many different bases unless there's extra detail or it's a specific kind of question. Okay, so I hope you like this video. See you in the next one. Thank you.